You know, there's an invisible conversation happening all around you right now, every single second. Today, we're going to pull back the curtain on something really fundamental. When your devices talk to each other, who are they actually talking to?
I mean, really think about it for a second. When your computer sends an email, or your phone pulls up a website, or your smart TV starts streaming a movie,
is it like a private whisper just between two devices? Or is it more like a group chat with a few select friends? Or is it a full-blown public announcement for everyone in the room to hear? Well, these aren't just metaphors. They are the actual core principles that make our entire digital world work.
Welcome to Super Courseva. Unlock the secrets of the internet and master computer networking. Let's dive in.
All right, let's kick things off with the one you use the most by far. It's the private one-on-one message. And in the world of networking, we call this Unicast.
the best way to picture this is a direct phone call or sending a private DM to a friend. When you go to a website, your computer starts a totally private Unicast conversation with that website server. It's a straight line, a point-to-point connection, and it's meant for their eyes only.
So what it really boils down to is this. Unicast is simply one sender talking to one very specific intended receiver. That's it. The whole point is to make sure nobody else gets to listen in on that data exchange.
And this is where the genius of it comes in. It's all about efficiency. A message gets sent out with a specific address on it. Now, every other device on the network sees it fly by, but they just need a quick glance at that address to say, nope, not for me, and they just ignore it. No wasted time, no wasted processing power.
So how in the world do they know so fast? How can a device tell that a message is private without having to crack it open and read the whole thing?
Well, the secret is this tiny, really elegant piece of engineering. It all comes down to the hardware address, what we call the MAC address. If the very first bit of that long address is a 0, the network hardware knows instantly. This is a unicast frame. It's a private message. It's that simple. Okay, that's one-on-one. But what if you need to talk to a specific group of devices? Not just one, but definitely not everyone. Well, that's where our next method comes in. Welcome to Multicast, the official group chat of the network.
And honestly, the perfect analogy here really is a group chat or a big conference call. You're not just talking to one person, but you're not shouting to the entire world either. You're sending one single message to a specific group of members who have all agreed ahead of time to listen in.
So, Multicast is the network's go-to method for one-to-many communication, and it is incredibly efficient for things like live video streams. Think about it. One source can send a single stream that thousands of people can tune into, instead of having to send a separate, heavy video stream to every single person.
How it works is pretty clever. It relies on devices subscribing to a multicast group. They basically raise their hand and tell the network, hey, if you see any messages for this group, send them my way. If a message comes along and a device isn't on the list, it's just thrown away instantly. Super efficient.
And just like with our private messages, there's a dead giveaway right in the address itself that tells you it's a group message. Any guesses what it might be?
Yeah, you probably guessed it. If a 0 in that first bit means private message, then a 1 in that exact same spot tells the network hardware, hey, this is a multicast frame. It's for a group. It's just a simple binary switch that completely changes who's listening.
Okay, so we've got private DMs and we've got group chats. But what happens when a device shows up to the party and has no idea who to talk to? It has to do the only thing it can, shout into the void and hope someone answers. This, my friends, is a broadcast.
It is literally like shouting through a megaphone in a packed room. A broadcast message is specifically designed to be heard and, more importantly, processed by absolutely every single device on the local network. There's no ignoring it.
This is what we call true one-to-all communication. One sender sends out a message, and the recipient is everyone, every single device on that local network. It's the digital equivalent of a town crier making a public announcement. And it has a very special, very memorable address. All Fs. When a device on the network sees a message addressed to FFFFFFF, it knows it has no choice. It has to stop what it's doing and process that message.
Now, this is absolutely crucial for how networks get up and running. When your laptop first connects to a Wi-Fi network, it might send out a broadcast basically yelling, hello, is there a router around here? I need an IP address. Every device on the network has to listen to that, but only the router is going to bother responding.
So we have the private whisper, the selective group chat, and the megaphone shout. Let's put all three of them side by side and see how they really stack up.
From a bird's eye view, the difference is pretty straightforward.
You've got Unicast, which is your classic one-to-one chat. Then you've got Multicast and Broadcast over on the other side. They're both forms of one-to-many, but as we saw, with a really crucial difference in who gets the message.
And this table really brings it all home. For Unicast, our one-to-one private whisper, the big clue is that first bit in the MAC address being a 0. For Multicast, the group chat for a select few, that same bit flips to a 1. And for Broadcast, our megaphone shout to absolutely everyone, it gets that special all Fs address. Each one has its own job and its own unique fingerprint.
So why does any of this actually matter? Well, because without these different ways of talking, our networks would just grind to a halt. They give us critical efficiency, which prevents your phone from having to waste its battery processing every Netflix stream happening on your home Wi-Fi, and they enable discovery, which is the whole reason your laptop can find the router in the first place.
So the next time you open a web page or stream a song, just remember, these private messages, group chats, and public announcements are all flying back and forth under the hood. It really makes you wonder, what other invisible rules and hidden protocols are working tirelessly in the background just to make our complicated digital lives feel so seamless?